Properties of angles here. I'm going to just go through these quickly individually. Vertical angles, they're congruent to each other. So whatever measure of angle ABC is, it's going to be the same angle measure as DBE. Or similarly, angle ABD is going to be the same angle measure as CBE. Okay, so if you see one dash mark like this, one arc, um, anything with that one arc will be congruent. So you might see more than two angles labeled with the same dash or arc or whatever. That means they're all congruent to each other. So you see this one, it's got two little arcs on it. Um, that means they're congruent to each other and it's different than these two. Okay. Let's see here. Complementary angles are any two angles that add up to 90 degrees. They can be connected like angle 1 and 2 here, or they can be separate, but if they add up to 90, you say they're complementary. Okay? And then there's supplementary, and those are any two angles that add up to 180 degrees. So same thing as before, they can be like a linear pair like this, or they can be just separate angles and then they add up to 180. Those are still supplementary angles, okay? Um, and then I just used that word linear pair, and linear pairs are supplementary because they are two angles shared on a straight line, and a straight line is technically a 180 degree angle. Again, that's because if I were to do a straight line, that's going to be a half circle traveling 180 degrees if I were to rotate from one end to the other. Okay? Vertical angles are congruent. Complementary angles add to 90 degrees, and supplementary angles add to 180. And angles in a linear pair are supplementary, which means they add up to 180 degrees. Example 2, it says find the measure of two supplementary angles if the difference in the measures of the two angles is 18. So this is a word problem here, and we're actually going to have to create some equations to solve this. So it's got some key information. It says two supplementary angles, and what you know about two supplementary angles is that they're going to add up to 180 degrees. So I don't know what my angles are yet. So I'm going to call the first one angle A and the second one angle B. And I'm going to add those two together and equal that to 180 degrees. Okay? And what I'm going to do for the next equation, or this next part of the sentence, we'll make another equation, I should say, is it says the difference in the measures of the two angles is 18. So it says the difference is 18. So I'll just say angle A minus angle B equals 18. Okay? I'll just put the little degree sign. There are a lot of different ways you could move forward with this process of solving for whatever angle A and angle B is. In Algebra 1, you should have learned about the elimination method and the substitution method. And that's used when you have multiple equations and you're trying to get rid of a variable, right? So let me put it to you like this. A two-variable equation, if you just have one two-variable equation, there's an infinite number of answers. But if you have a one-variable equation, then there's just going to be one answer. So what am I trying to say here? I want to get this down to one variable. So how can I do that? Well, if I use the elimination method says that you can add your two equations together and create one singular equation. And then the only reason why you would want to do that is you notice that one of your variables will go away. So when I add these two equations together, look, I have two angle A's. So I'm going to put two angle A's. And then look at my B's. I have plus B minus B. I have zero B's. I'm just going to go ahead and cross those out. Equal 180 plus 18, the sum of that. So 180 plus 18, that's 198. Okay, so I have 2 angle A's equals 198. Why don't I just divide this by 2? Okay, if I divide this by 2, I have 1 angle A equals, let's see here, 198 divided by 2, 99. So I didn't give myself enough space, right? Angle A equals 99 degrees. Okay, so angle A equals 99 degrees. What you want to do is you want to go back to either one of your two equations and plug in 99 instead of writing angle A. So it doesn't really matter which one you plug it into. Whatever one looks like less work is what I would recommend you do. But you have to plug it into one of the original ones. So I'm going to do the first one. I'm going to do 99 plus angle B equals 180. Okay? Um, so you could try to solve this in your head, or you could just say, hey, I have a 99 that I can minus to the other side. And why would I minus to the other side? Because I want to move it to the other side. It's a positive 99. The opposite of positive is negative. So minus 99, 180 minus 99 is going to be 81. So this says plus B, so it's just saying B, angle B equals 81 degrees. Okay, you can check your work by using the other equation. The other equation was A minus B equals 18, right? So what's 99 minus 81? That's 18. So it works in the second equation as well. Okay, so we got our two answers here. Angle B is 81 and angle A is 99 degrees. To go over is about perpendicular lines. When you have lines that intersect each other in a perpendicular fashion, they're going to create 90-degree angles, okay? So if you were to use what you know about vertical angles, if these lines intersect at 90 degrees, that means this is a 90-degree angle. And then since these are straight lines, they form a linear pair. And so if this is 90 degrees, then the angle next to it is 90 degrees. And then so you could apply that same thought process to this. This is 90, that's 90. So basically, if you have two perpendicular lines intersecting, you're going to create 4 perpendicular angles. Okay, so what I want you to write here is just perpendicular lines intersect to form right angles. Please do not assume that an angle is perpendicular unless it is marked or given. So what I mean by that is I could draw an X for you like this with these intersecting lines, but you don't know for sure that they're perpendicular angles or perpendicular lines, excuse me, unless you see a right angle marked. So this is the right angle marked. Generally, we see it turned on its side like this. Um, but yeah, that's the right angle notation, I guess you will. Okay, so we're going to apply that knowledge to this in example 4. It says find x and y so that PR and SQ are perpendicular. Okay, so we want PR and SQ to be perpendicular. So PR is this line, SQ is that line. So if they're perpendicular, I'm going to have a right angle pretty much on these corners. So that means I have a right angle overlapping on this one. So let me highlight a different color. These right here, these are complementary angles. So angle STW, if I add that with angle WTR, that's going to add up to 90 degrees. That's how you're going to start this first problem. Because also, if you notice, the STW is 2x, and then the WTR, that's 5x plus 6. Those are two x variable angles, right? Whereas if you look at this one, angle PTQ, that's using the letter y. So I want to deal with that later. I'll try and solve with the x's first. Okay. So as I said before, because I know that these lines are perpendicular, I know I have 4 right angles. And so if this makes a right angle going from ST to R, then I add these two together and equal it to 90. 5x plus 6 equals 90. And I'm going to combine like terms. I have 2x plus 5x, that's 7x. And then that 6 is not a like term. It does not have an x with it. So what you should do is you should get it to the other side with the 90 because those are both constant numbers. They don't have a letter with it. So the opposite of 6 plus 6 is minus 6. So I'm going to minus 6 to the other side. Okay? So I'm going to bring down that 7x and then I'm going to equal it to 90 minus 6 is 84. Okay? 7x means 7 times x. So to get rid of this 7, I'm going to do the opposite of times, which is divide. Okay? And so 84 divided by 7 is going to be 12. So I get x equals 12. All right? The information, all I need to do is plug in 12. So let's see here. 2x, 2 times 12, that's 24 degrees. Okay, that's what this angle is right here. And then 5x plus 6, I got 5 times 12, that's 60, plus 6 is 66. And then you can do a quick little check. Is 66 plus 24, does that equal 90? Yes, it does. So that's how you know you did it right. When you add these two angle measures together, they equal 90. Okay? And then solving for the y variable is going to be pretty straightforward. It's just one angle, 4y minus 2. That's already a right angle. So I'm just going to write 4y minus 2 equals 90 degrees and solve for y. I see there's a minus 2 that I can plus to the other side. Okay, I would not combine it with the 4y because it does not have a y with it. That's why I have to add the 2 to the other side with the 90 because those are the common terms. They do not have any letters in common. They're both constant numbers, if you will. 90 plus 2 is 92. Bring down the 4y. 4y means 4 times y. So if I were to divide both sides by 4, I would get my answer for y. And so that's going to equal 92 divided by 4, doing that off the top of my head, was that like 23? Yeah, I think that's 23. Okay? And then I would plug it back in, but 4 times 23 is going to equal 92. When you subtract 2, you get 90. So, yeah, we already knew it was going to equal 90. Okay? This last question says, what is the measure of angle STW and measure of WTR? So STW, let's look at that. STW, oh, that's 24. And then STR, oh, sorry, WTR, that's 66. I answered those questions already. This part 2 section to a close. Feel free to watch part 3. I'll have that linked in the description. Thanks.